Let's talk about variables. So I've got my Python terminal pulled up. If you're running, actually, I just got my terminal pulled up. This is my shell. I'm going to be running Python, but I'm going to be running bpython. If you don't have bpython, that's fine. I expect you to run just regular Python, and that's okay. I like using bpython because it gives me one, pretty colors, allows me to differentiate between something that's correct and incorrect instead of the standard black and white screen. And two, if I ever have to paste between a file and into the Python idle or terminal, then it allows me to do so without any issues most of the time. Because if you try to do that in Python, in regular Python instead of bpython, you often run into formatting issues between file and not file. So with that said, I'm going to be running bpython. If you have a Mac, you can install bpython with pip or with brew. If you don't have a Mac and you have Linux, I'll give you guys links in the description below and on how to install bpython. So again, not necessary. You can follow along with just regular Python if that's what you wish. If you have if you want to just do regular Python, you just open up your terminal and type in Python, and that's it. And then it'll get for this glorious screen. You don't have to have the same version, not required right now at the moment. But if you have bpython, you can just type in bpython, and then you just bring this up, and that's fine. So now let's talk about variables. Now, before we talk about variables, let's talk about data types. So there are specific types of data types, or rather few types of data types in Python. So one of them, or rather all of them, are going to be, you have string, you have an int, you have a float, and that's pretty much it. There are others where it's like hexadecimal and binary and non-binary and so on, but we're not going to worry about that too much right now. We're just going to stand with the easy standard types right now at the moment. So let's start with a string. So what is a string? A string is a set of characters together. And when I say characters, I mean each of these letters, including the spaces. So S, E, T, and the space, and then the O and F, and space, and so on. All of them together in this format where they are together by these double quotes at the beginning and the end is called a string. This is one string, or one set of string. If I type in type and then open paren and close paren, it says it's of class string. So again, if I don't do that and I just type that in, and it returns the string. Fairly simple. So if I do the same thing on an integer, which is 5, it gives me class int. If I do the same thing on a floating point number, which is 5.0, it gives me class type float. That's how I determined what it is. Now, you might be wondering, well, what about type double, where you have double length of the floating point array? So that's true. Python does have a double as well, but it's built into the type float. So it automatically designates what's a type double and what's a type float. If you have a long enough integer value, or sorry, a floating point value where it's more than the 64 bits that's necessary, then it will be type double. However, it won't actually return type double. It's just assumed type double. So going forward, we don't need to know too much about doubles and floating points as of yet. We just need to know that these are some of the basic, not all of them, but these are some of the basic data types that Python supports. Now let's talk about variables. So if I, for example, say that I want to store the number 5 in a variable, you can easily say x is equal to 5, just like how you used to do math back in high school, for example, right? In high school, you'd always say, oh, 3x plus 21 is, what is 3x plus 21? And you solve for x. Well, if x is equal to 5, 3 times 5 is 15, plus 21 after that is, what, 15 plus 20 is 35, so it's 36. So this will be whatever 36 is. So 3x, oh, I'm sorry, I didn't actually type in x is equal to 5 yet. So, oh, wait, no, I did. 3x, 3 times x plus 21 is 36. So Python doesn't actually designate that this is a times, that when you type in 3x, it's actually just an object, but it's an invalid syntax. So you actually have to type in the times part out. So that was that error, my bad. I should have known that. Anyways, so, but still exactly simple. much like in high school. However, never, ever, 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 ever name your variables X or a singular letter or something that doesn't actually define what the variable is for. For example, if you run a used car lot, right, you want to know how many cars have been sold and how many cars are still in the lot left. So what you can do is you can say that my total number of cars are 500 is equal to 500, not X, just 500. And then I've sold cars equal to 124. So cars in lot, the total number of cars left, so cars in lot is equal to total number of cars minus sold cars. And say cars in lot is equal to whatever's left, 376. Now, look at how my variables are named, right? They are descriptive. Total cars is how many cars I've started with, and how many cars I've had at least for whatever this period is. And the sold cars is how many I've sold within this month or whatever the selling period is. Maybe it's a quarter. And then I've got 376 cars in my lot left right now. As of right now, I've got 376 cars left in the lot. Now, my variables are very descriptive of what they are. Even if you have a full-on sentence for your variables, you want to make sure that your variables are describe the name of the variable, describe what the variable is for. Never, ever, ever make your variable singular letter. Not A, not B, not X, not Y, nothing. Nothing like that. You must make them descriptive. So, the next thing I want to point out about my variables is these underscores. Wherever I normally would have spaces, I have underscores. Now, in Python, this is called snake casing, where you have an underscore in place of spaces. And this is perfectly fine. In Python and Pep8, at least at the time of right now, actually prefer snake casing. Some other programming languages prefer camel casing like this. And in programming languages like Golang and so on, this is fine. However, in Python, if you ever use Pep8 or whatever Pep format you would like to use, snake casing is what is preferred. Now, you might not know what Pep8 or why it's preferred. This is called linting. Linting, it gives you a set of standards on how to write your program so that everybody understands it, whether you understand it within your organization, whether your partner understands it within your organization, or whether somebody else in a different organization understands it. This way, we all follow a standard format. Now, the camel casing is actually allowed. This is perfectly valid. However, if you ever use a linting formatter, and we'll go over that in the future, it will complain, hey, don't do this, write it in snake case instead. So it's more of a suggestive thing rather than an enforced thing. However, it's best to follow the suggestions as much as possible so that everybody can understand what your program is doing at all times, and there's no differentiating thing between how this person writes and how that person writes. Moving on into strings. So we already actually not into strings, into ints. So we talked about how ints work. It's just really simple. It's one singular character. You can add and multiply and divide with them, and you can do the same thing with a float. However, if you use a float, you'll get back a float. If you use an int, you'll get back an int. You can't do multiplication with string. That just doesn't work. However, if you have a number in a string with these quotes, you can convert it. So let's just say that I have this, and if I do a type on that, even though it's a number, it's actually a string because it has in quotes. So I can convert my string into an int. So let's say that I want to convert my 5 into an int because it is an int. It's not a float, so it won't convert to a float, but I can convert it to an int. So if I say int 5 in string format, it says 5. So let's say that my my total cars is equal to 5 in string format. So I can say my total cars is equal to, I can say int my total cars, and it gives me back 5, just like how I just did it prior to this. If I want to, however, if I look at it now, my total cars still says a string. It still returns a string because it's got these quotes in it. And the reason why it's doing that is because I didn't actually save the conversion. So if I were to save it, so let's say my new value of total cars is equal to the integer conversion of my previous value of total cars, which was a string format. And now if I look at total cars, it says 5, which is type int. So that's just some basic on conversion. If I wanted to make it a float, I can do the exact same thing. So float total cars. And it gives me a 5.0. And I can save it the same way. So that being said, let's move on to from conversion into back into string for a little bit. Because you probably noticed that there's double quotes and then there's single quotes. So both are valid. And because both are valid, we want to be able to know the caveats between both of them. For example, let's say that I have a sentence that says the director's cast is unhappy. I've used this in the past before, and so on. So if you look at this, it says that the start of the sentence is here. We know that the end of the sentence is here because it's got these two particular single quotes, just like how this has two single quotes and it's of type string. However, because of this apostrophe right here, which is technically also a single quote, Python thinks that the sentence finishes here, and then therefore it tries to compute the rest, and therefore it fails. So because it fails, how do we get around it? Well, one thing we can do is have it in double quotes. So the director's cast is unhappy. I've typed this out previously, that's why you're looking at the history of it. So the director's cast is unhappy, and this works. It's a full-on string, there's no errors, and it's got my apostrophe. However, what if I want to keep my single quotes? Well, I can do that if I have an escape character. A forward slash, starting from the left, going to the right, this is called a forward slash. A forward slash says gloss over the next string, or the next character. Right? Do not try to compute it. And so Python does exactly that. So therefore, the forward stroke itself, or the forward slash itself, is removed, and Python does not compute the next character. And it returns the director's cast is unhappy. So now you know we can do it either way we want. Have double quotes, have single quotes with escape characters, have double quotes with escape characters. We can do all of that. If I want to say this is the quote of the day, and it is, my quote is live life like it's your last day. End quote. Now you already have a issue, right? Python again thinks this is the beginning and this is the end, and then it tries to compute all of this. You can tell them by my colors because it's going to run into a failure, but going back into it, this is the beginning, this is the end, and that's a problem. So what I'm going to do is I'm going to escape them. So I can escape this one because this is where my quote starts. However, I run into a problem with this one because it will still try to compute it. It actually tries to compute the very last quote and says, you need to finish this. Well, we start this. This one gets glossed over, but this one doesn't get glossed over. So it ends here, and then it starts here, and Python is looking for a finish. Since it's looking for a finish, we want to also make sure that this one gets glossed over, and then we have our quote. This is the quote for the day. Of the day. Live life. Wow, I suck at spelling. Like it's your last day. Live life like it's your last day. Man, say that 5 times in a row. Anyways, so that's enough with strings. That's enough with floats. That's enough with integers, and that's pretty much enough with variables. Make sure that you understand that variables have their names fully detailed. And with this video done, let's go on to the next one. In the next video, I'm going to go ahead and explain the different more data types, but more data types that's specific to Python, like dictionaries and lists or arrays and tuples. Not so much on the tuples, but I'm going to go ahead and gloss over it at least like a little bit. But more on dictionaries and arrays, obviously. So I'll see you guys in the next video.